So yun, good afternoon po sir. So kami po yung group 2 from EE2D. So yung topic na na-assign sa amin is about Bessel function. So MATH223, Engineering Math for EE. So next. So Republic of the Philippines, Nueva Ecija University of Science and Technology, main campus from Sumakab Este, Cabanatuan City. So kami from College of Engineering, Electrical Engineering. So second semester, school year 2021-2022. MATH223, Engineering Math for EE. So kami po ang bumubuo ng group 2. So my name is Centro Leonel Patrick B. And my groupmates are Dela Cruz Jan Jervin, Fuentes Jan Rocky, Ocampo Michael Angelo, and Tarucan Alje from EE2D. So next. So dun muna tayo sa first part natin. Alamin muna natin kung ano yung Bessel function. So yung Bessel function is first defined by the mathematician Daniel Bernoulli and generalized by Friedrich Bessel are canonical solutions y of x of Bessel differential equation. So dito makita natin x squared is equal to d squared y over dx squared plus x dy over dx plus x squared minus alpha squared is equal to y equals 0. So para sa mga arbitrary complex, yung number na alpha, the order to order siya ng Bessel function na kung saan yung alpha and negative alpha nagpo-produce siya ng same differential equation na kung saan yung mga conventional and defined differential Bessel function dito sa dalawang values na kung saan yung way that yung Bessel function are mostly moot siya na kung tawagin is function of alpha. So next. So Bessel functions are the radial part of the modes of vibration of circular drum. So sunod tayo, Bessel function, also called cylinder function, any of a set of mathematical functions systematically derived around 1817 by the German astronomer, yun nga, A.C. Friedrich Wilhelm Bessel, na kung saan yung investigation niya ng mga solutions of one of Kepler's equation of planetary motion. Particular functions of the set had been formulated earlier ng Swiss mathematician na si Daniel Bernoulli. So, siya yung nag-study ng mga oscillations, mathematicians, and mga chains suspended by one end, and nag-study siya ng mga chain suspended and one end. Tapos yung si Leonard Euler naman, nag-analyze siya ng vibrations of a stretch membrane. So next, ito may konting description lang kay Friedrich Wilhelm Bessel. So isa siyang German astronomer, mathematician, physicist, and geophysicist na kung saan siya yung first astronomer na nag-determine ng reliable values for distance from the sun na to another star by the method na tinatawag na parallax. So according yan sa Wikipedia. So pinanganak siya noong July 22, 1784 sa Minden, Germany. Ang namatay no March 17, 1846. So next tayo. So dito tayo sa first equation natin, yung Bessel differential equation. So yung Bessel functions arise as solution of the differential equation. So dito is equal to x squared double prime plus xy prime plus x squared minus n squared y is equal to 0. N is greater than or equal to 0. So next naman yung which is called yung mga differential equation, yung mga general solution of 1 is given by y is equal to c sub 1 j sub n equal to yung x, tapos yung c sub 2 y sub n equals siya g. So next tayo, so sa the solution from j n x which has a finite limit as x approaches 0 is called the Bessel function. So dito makikita natin yung first kind and order n, yung solution y sub n was x, na kung saan wala siyang finite limit or is unbounded. As x approaches 0, is called naman siya na Bessel function of the second kind and ordered n or Newman function. So dito makita natin if dependent variable x in 1 is changed to lambda x where lambda is constant na nagre-result siya ng equation na is equal siya sa x squared y double prime plus xy prime plus lambda squared x squared minus n squared y is equal to 0. Na kung saan yung general solution is y is equal to c sub 1 j sub n lambda x plus c squared y sub n lambda x. So, next. So, yung function na yun, function first aroused in Daniel Bernoulli's investigation na kung saan yung oscillations of a hanging chain nag-appear siya sa theory ni Euler na kung saan yung vibration of a circular membrane in Bessel ay nag-study siya sa mga planetary motion. So next tayo. So sa Bessel function of the first kind, dito na-define natin yung Bessel function of the first kind of ordered n as j sub n x is equal siya sa x raised to n all over 2n minus n plus 1 parenthesis na 1 is equal to x squared 2 all over 2n plus 2 plus x raised to 4 all over 2 times 4 2n plus 2 and close and open parenthesis 2n plus 4. Or pwede rin siya na gawing j sub n x is equal to summation of infinity r is equal to 0 and negative 1 raised to r x over 2 n plus 2 sub r all over r factorial n plus r plus 1. Tapos dito kung saan yung n plus 1 isa tinatawag siyang gamma function na kung saan yung n is a positive integer na kung saan yung n plus 1 is equal siya sa n factorial is equal to 1. So dito rin yung for n is equal to 0, yung 6 becomes j sub o sub x is equal siya sa 1 minus x squared all over 2 squared plus x raised to 4 2 squared 4 squared is equal to x raised to 6 2 squared 4 squared 6 squared and so on and so forth. And sa susunod na part, yung series na converges for all x na gagraph siya sa j sub o is equal to x and j sub 1x ay makikita natin dito na shown sa figure na 10.10 minus 1 na kung saan yung n is half an odd integer and jn and x can be na-express siya in terms of sine and cosine. Makikita natin yon sa mga problem na i-discuss namin sa mga susunod na slides sa 10.4 and 10.7. So yung a function of j minus n is equal to x, n is greater than 0. So can be defined siya by placing n by minus n in 5 or 6. So if n is an integer, then makikita natin dito sa problem 10.3 na j minus n is equal to x is equal siya sa negative 1 and j sub n x. So next. So dito another description lang sa formula, kapag yung n is not an integer, so yung j sub n x and j minus n x are linearly independent siya, and for this case, mga general solution of 1 is mag-i-equal siya sa aj sub n x plus bj minus n x. So n is not equal to 0, 1, 2, 3, and so on and so forth. So sa Bessel function naman of second kind, we shall define the Bessel function of the second kind order n as, dito makita natin y sub n x is equal siya dun sa may j sub n x cos pi minus j minus n x all over sin n pi. So dito makita natin n is not equal to 0, 1, 2, and 3. Kaya limit is equal siya sa p is equal to n j sub p and x cos p sub pi and j minus p is equal to x all over sine p pi. So dito makita natin yung n is equal siya sa 0, 1, 2, and 3 and so on and so forth. So dito for the case where yung n is 0, 1, 2, and 3, we obtain na yung following series expansion for y sub n is equal to x. And then natin dito, y sub nx is equal siya sa 2 over pi ln x over 2 plus y. So yung j sub n x is ma-minus mo siya sa 1 over pi summation of n minus 1 all over k equals to 0. And yung n minus k is equal to 1 factorial. So x over 2k is equal to n. And for continuation, ima-minus siya sa 1 pi over summation of infinity k is equal to 0 and negative 1k and p and k plus pn plus k is equal to x minus 2, x over 2, 2k plus n is equal to k factorial, n plus k factorial, where ang lalabas doon ay 0.577 to 156. Yun yung tinatawag na Euler's constant. And yung P is equal siya sa 1 plus 1 half plus 1/3 plus 1 over P. Or yung P is equal to 0. So sa generating function for J sub nx, yung function is equal siya sa EX over 2 is equal siya sa t minus 1 over t. Equal siya sa infinity summation of n equals negative infinity j sub n x t sub n. Na kung saan dito tinatawag siyang generating function for Bessel function for of the first kind of integral order. Na kung saan yung very useful for obtaining properties of the this function for integer values. Na kung saan yung n can often to be proved for all the values ng n. So dito, makita natin yung mga recurrence formulas. So yung mga following results dito are valid siya na values ng n. So sa number 1, j n plus 1 is equal to x is equal to 2 sub n over x, j sub n equal to x minus j n minus 1 is equal to x. And yung isa naman, j prime sub n is equal to x equals 1 half jn minus 1x. Na saan equal siya sa jn plus 1x. And yung xj prime nx is equal siya sa nj sub n. X is minus siya sa xj sub n plus 1x. And for next number, sa number 4, yung xj sub j prime sub n x is magiging equal siya sa xj sub n minus 1x minus nj sub n x. This d over dx is equal to x sub n j sub n x close is equal to x raised to n j sub n minus 1x. And for the last naman na pwede maging following result na magbavalue siya sa values ng n is d over dx is equal to x minus n j sub n x close and open. So equal siya sa negative x minus n j sub n plus 1x. So dito sa anim na to, parang if n is an integer, this can be proved na using generating function. Na note na yung results ng 3 and 4 ay equivalent siya respectively sa number 5 and 6. So yung functions y sub nx, nagsasatisfy siya exactly the same result as those above where y sub n and x replaces j sub n x. And next tayo, yung functions related siya sa Bessel function. So number 1, yung Hankel function of first and second kinds are defined respectively by h is to 1 over n x is equal to j sub n x plus y sub n x. And h sub n x is equal to j sub n x minus y sub n x. So for number 2 naman, yung modified Bessel functions na tinatawag, kung saan yung modified Bessel functions of the first kind of order n ay ln of x is equal siya sa I is equal to n, j sub n, I sub x is equal to e n pi I over 2 j sub n I sub x. Kapag yung n naman is integer, pwede siyang gawing I minus n is equal to I sub n j sub x, and I minus n equals to ln x. But if n is not an integer naman, pwede siya maging I sub n x, I minus n x are linearly tinatawag siya independent. Na kung saan yung modified Bessel functions of the second kind of order ay dinidefine dito sa k sub n over x is equal siya sa pi over 2 I minus n x minus I sub n x all over sine n pi. So dito makita natin n is not equal to 0, 1, 2, 3. And dito tayo sa baba, limit of pi over 2 as p approaches n is L minus p x minus ip sub x over sine pi. So n is equal to 0, 1, 2, and 3. So this function nagsasatisfy siya sa mga differential equation na kung saan yung x squared double prime plus x y prime minus x squared plus n squared y ay mag-i-equal siya sa 0. Na kung saan yung general solution of this equation ay y is equal to c sub 1 I sub n x plus c squared k sub n x. Or pwede rin siya n is not equal to 0, 1, 2, and 3. So yung y is equal to a sub I sub n x plus b sub I minus n sub x. So para sa mga susunod na slide ay i-report siya ng mga groupmates ko. So dito tayo sa Baker K function. So for the next details, i-report siya ng groupmates ko.
My name is General C. Fuentes. Baker K function. The function Ber sub n x and Bay sub n x are the real imaginary parts of J sub n I raised to 3 over 2x, where I 3 over 2 is equals to e raised to 3 pi 1 over 4, and square is also equals to square root of 2 over 2 times 1 minus I. Ang sinasabi dito na yung function daw na Ber sub n x and yung Bay sub n x ay real and imaginary part siya ng J sub n I 3 over 2 x, where I 3 over 2 is equals to e 3 pi 1 over 4 equals to square root of 2 over 2 times 1 minus I. Sabi din dito, J sub n I raised to 3 over 2x is also equals to Ber sub n x plus I Bay sub n x. Dito naman tayo sa Ker and K. The function Ker sub n x and K sub n x are the real imaginary parts of E minus n pi 1 over 2. K sub n I raised to 1 over 2x, where I 1 over 2 is equals to e pi 1 over 4 is also equals to square root of 2 over 2 times 1 plus I. Dito naman daw sa Ker and K, real din siya. Siya daw yung real and imaginary parts ng formula na e minus n e raised to negative n pi 1 over 2 kn k sub n I 1 over 2x. Sinasabi dito na ang e raised to negative n pi 1 over 2 kn k sub n I 1 over 2x ay equal siya sa ker n or ker sub n x plus ik k sub n x. Parang pareho lang din siya ng sub and bay. The function are usable in connection with the equation. The function doon nito is useful siya sa connection gamit yung mga equation. X squared y double prime plus xy prime minus I x squared plus n squared times y is equals to 0, which arise in electrical engineering and other fields. Nakikita daw to sa electrical engineering and sa other fields. Madalas siyang gamitin. The general solution of this equation is, ito yung pinaka-general solution niya, is yung y equals to c sub 1, j sub n, I raised to 3 over 2x plus c sub 2, k sub n, I 1 over 2x. Equation transform into Bessel equation. Yung equation daw is transform siya into Bessel equation. Yung equation is ito yung in the equation. X squared y double prime plus 2k plus 1 times x y prime plus a squared x squared raised x raised to 2r plus beta squared times y equals to 0. The k, ar, and beta are constant. As the general solution, ito yung, kumbaga yung k, a, r, and yung beta, constant sila. Tapos ito yung pinaka-general solution nila. Y equals x raised to negative k times c sub 1, j sub k or r, ax, r, over r plus c sub 2 y k over r times ax raised to f over all over r, where k is equals to square root of k squared minus beta squared. If a equals to 0, the equation is solved as an Euler or Cauchy equation. Let's go to the asymptomatic formulas for Bessel function. For large values of x, we have the following asymptomatic formulas. Which is yung j sub n x square root of 2 over pi x cosine close and open parenthesis x minus pi over 4 minus n pi over 2. And yung other niya is yung y sub n x square root of 2 over pi x sine close and open parenthesis x minus pi over 4 minus n pi over 2. Dito naman tayo sa zeros of Bessel function. We can show that if n is a real number, j sub n or x is equals to 0 has an infinite number of roots which are all real. The difference between successive roots approaches pi. As the root increase in value, this can be seen from the asymptomatic formulas. We can also show the roots of j sub n x is equals to 0 lie between the dose of j sub n minus 1 x is equals to 0 and j sub n plus 1 x is equals to 0. We have similar remarks that can be made for y sub n or x. Sinasabi dito na makikita daw natin dito na yung n is n real number, tapos yung j sub n daw, meron siyang infinite number of roots, which is yung lahat daw sila is real. The difference, yung may difference sila sa successive root approaches to pi, as the roots increases the value, yung root daw is yung nag-i-increase yung value niya. Makikita doon natin ito sa may, ginamit natin ngayon sa asymptomatic formulas. Or orthogonality of Bessel function. If lambda and mu, if lambda and mu are two different constants, we can show from the previous problem that the integral of 1 over 0 x j sub n close and open lambda x j sub n close and open parenthesis mu x dx is equals to mu j sub n lambda j prime n lambda minus lambda j sub n times mu j sub n prime lambda. Makita natin sa problem na to na problem na to is yung magiging sagot niya is yung integral of 1 over 0 x j 2n lambda x dx is equals to 1 over 2 close and open parenthesis j prime 2n lambda plus close and open parenthesis 1 minus n squared all over lambda squared times j 2n lambda. Makikita daw natin dito na sa 27 yung which is yung unang nga nating given is yung makikita natin dito na yung if yung lambda and yung mu are any two different roots of the equation, therefore r j sub nx plus x ay s x j n x is equals to 0, where yung r daw and yung s na ay constant. Then ang magiging sagot dito is yung integral of 1 0 x j sub n lambda x j sub n mu x dx is equals to 0, which states that the function square root of x j sub n lambda x and square root of x j sub n mu x are orthogonal in 0, 1. Sabi dito, na-instate daw yung function na to na square root of x j sub n lambda x and yung square root of x j n mu x ay orthogonal in 0, 1. Note that as special cases of 29, which is yung rj sub n x plus sx jn x is equals 0, we can see that yung lambda and yung mu can be any two different roots of j sub n x is equals to 0 or j x is equals to 0. We can also say that a function j sub n lambda x and j sub n mu x are orthogonal with respect to the density of the function x. Next. Let's go to the series of Bessel function. As in case of Fourier series, you can show that if x satisfies the Dirichlet condition, then at every point of continuity of f of x in the interval of 0 less than x less than 1, there will exist a Bessel series expression having the form f of x equals a sub 1 j sub n close and open parenthesis lambda sub 1 x plus a sub 2 j sub n close and open parenthesis lambda sub 2 x plus and many more. Pwede siya maging susunod na issue ganun ito. A sub 3 j sub n lambda sub 3x. Baga parang tuloy-tuloy lang siya. Is equals to summation of D is equals to 1 infinity. A sub D, J sub N, lambda D X, where lambda 1, lambda 2, lambda 3, lambda 4, or many more, are the positive roots of yung kanina yung sa 29, which the R over S is greater than 0. So S is not equal to 0 and A sub D is equals to 2 lambda 2D all over to close and open parentheses lambda 2p minus n squared plus r squared over s squared j 2n lambda d integral of 10 x j sub n lambda p x f of x dx. At any point of discontinuity, the series on the right in 31, which is ito ngayon na sa taas yung f of x, a sub 1, jn, lambda 1, x, tapos yung mga kasunod pala. Converges to 1 over 2, f of x plus 0 plus f of x minus 0, which can be used in place of left side of the third one. Parang pwede siyang magagamit mo rin siya sa kasama nun sa third one. Left side. Next is yung in case of S is equal to 0, so that lambda 1 and lambda 2 are the roots of j sub n x is equal to 0, AD is equal to 2 square root of j 2n plus 1 lambda p lambda d integral of 10 x j is equal to lambda p x f of x dx. If r is equal to 0 and n is equal to 0, then the series 31, which is ito nga yung kanina, yung f of x, a1, j sub n, lambda 1, lambda sub 1, x. Tsaka yung kasunod niya is yung mahaba pa. Parang tuloy-tuloy pa. Start out with the constant term, a sub 1 is equals to 2 integral of 10 x of f of x dx. Let's go to the sample problem. Solve problems. Bessel differential equation. Use the method of Frobenius to find series solution of Bessel differentiation equation. X sub 2 y double prime plus xy prime plus x squared minus n squared y is equals to 0. Yung first step natin is assume daw natin yung solution. Assuming a solution, the form is, ito yung form niya, is y is equals to summation of c sub k x raised to k plus beta, where k goes from negative infinity to positive infinity, and c sub k is equal to 0 for k less than 0. We have, ito yung makukuha natin pag in-assume natin yung form na to is yung ganito. Close and open parenthesis, x squared minus n squared y is equals to summation of c sub k x raised to k plus beta plus 2 minus summation of pi squared c sub a x a plus beta is equals to summation of c sub k is equals to minus 2 x k plus beta minus summation of n squared c sub a x k plus beta x y prime is equals to summation of k plus beta c sub k x k plus beta. Next is yung differentiation. I-differentiate mo lang siya ulit. I-differentiate mo lang siya ulit. And yung makukuha mo sagot is yung x squared y double prime is equals to summation of k plus beta times k plus beta minus 1, which is, i-rewrite mo lang yung c sub k, x, k plus beta. I-relate mo lang siya pagka derive mo nung first term. X is yung, then i-add mo lang siya. Then by addition, mag-add ka na dito. Summation of, close and open parenthesis, k plus b times k plus b minus 1 c sub a plus, close and open parenthesis, k plus beta, close c sub a plus c sub a minus 2 minus x squared c sub a x k plus a is equals to 0. Ito yung continuation niya. And since yung coefficient niya is yung kanina, yung halos nire-write lang natin is yung x k plus b beta plus b0. We find ito yung makukuha natin is yung close and open parenthesis k plus b squared minus n squared over c sub k plus c sub k minus 2 is equals to 0. Magliletangan. Letting k is equals to 0 in first, yung ito nga yung una natin, yung first, yung coefficient. Yung natin ng coefficient itong hinahanap natin yung yung una. We obtain na since c sub minus 2 is equals to 0, the initial equation beta squared minus n squared c sub 0 is equals to 0, or assuming that c sub 0 is not equal to 0 and the beta squared is equals to n squared. Then there are two cases given by beta is equals to negative pi and b is equals to x. We shall consider that the first case b is equal to n and obtain the second case by replacing n by n. Mapalitan lang doon siya. Yung case number 1 is yung niya. Di ba ito nga nakuha natin ng case number 1 yung yung b equals n. In the case number 1 becomes, ito yung magiging yung magiging kapupuntahan niya. K, close and open parenthesis, 2n plus k, c sub k plus ck minus 2 is equals to 0. Putting k, lagyan natin value ngayon yung k dito. Putting k equals to 1, 2, 3, 4, 5, 6. Madami pa siyang kasunod. Successively in 2, we have, which is yung 2, ito nga yung nakuha natin yung sa case number 1. Yung c sub 1 is equals to 0, c sub 2 is equals to negative c sub 0, all over 2, close and open parenthesis, 2n plus 2. Tapos ito yung sa C3 is equals to 0. Sa C4, C sub 4 is equals to negative C over 2 all over C, 4. Close and open parenthesis, 2n plus 4 is equals to C sub 0, 2 times 4. Close and open parenthesis, 2n plus 2 times 2n plus 4. Baga parang tuloy-tuloy ulit siya. Thus, the required series is y is equals to 0, c sub 0 x raised to n plus c sub 2 x raised to n plus 2 plus c sub 4 x n plus 4 plus, baga parang tuloy-tuloy ulit siya. Parang mahaba siya tuloy-tuloy lang. And equals to c sub 0 x n close and open parenthesis 1 minus x squared 2 all over 2 close and open parenthesis 2n plus 2 plus x raised to 4 2 times 4 close and open parenthesis 2n plus 2 times close and open parenthesis 2n plus 4. Yung katuloy niya. Next is yung case number 2 naman is yung kanina pa. Yung kasunod ng b beta is equals to n. Ito naman yung case number 2. b is equals to negative n. Parang gano'n lang din siya sa kanina. I-replace mo lang yung n by negative n. Na sa case number 1 na natin. Same lang din siya. Y is equals to c sub 0 x minus n times 1 minus x squared 2 close and open parenthesis 2 minus 2n plus x raised to 4 all over 2 times 4 times 2 minus 2n, close and open parenthesis 4 minus 2n. Now, if n is equal to 0, both of the series are identical. Now daw, yung n is equal to 0 ay parehong series. Yung this series daw are identical or nakikilala na. If n is equals to 1, 2, 3, 4, 5, 6, and many more, the second series fails to exist. However, if n is not equal to 0, 1, 2, 3, 4, 5, and etc. And the two series can be shown to be linearly independent, and so for this case, the general solution is, ito yung pinaka-general solution is y is equal to cx raised to n, close and open parenthesis 1 minus x squared all over 2, close and open parenthesis 2n plus 2 plus x raised to 4 all over 2 times 4, close and open parenthesis 2 times plus 2 times close and open parenthesis 2n plus 4 and minus something and many more. Plus dx minus kung hanggang saan yung binigay sa'yo na n. Yun yung tutuloy-tuloy mo. Then, plus dx minus n, close and open parenthesis 1 minus x squared all over 2 times 2 minus 2n plus x raised to 4 all over 2 times 4, close and open parenthesis 2 minus 2n, close and open parenthesis 4 minus 2n. The cases, the cases where n is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, and etc. are treated later.
Bessel function of the first kind. Example ito ng Bessel function of the first kind. Ang formula ng Bessel function, itong x squared y double prime plus x y prime plus x squared minus b squared times y equals 0. Where b, yung b niya, yung order of the function or index of the function. Example. Ito yung example na ng pagsosolve ng isang Bessel function of the first kind. X squared y double prime plus x y prime plus x squared minus 1 over 9 times y equals 0. Napansin natin na yung formula, ang nabago lang yung v. Ang general solution ng Bessel function of the first kind, ito yung yx equals c1 j 1 over 3x plus c2 j negative 1 over 3x. Yung v ang value niya equals sa plus or minus 1 over 3. Yung 1 over 3, non-integral siya. Since v is non-integral, j1 1 over 3x and j2 1 over 3x are linearly independent. Ito naman yung equation ng jvx. Jvx equals sa xv summation of m equals to 0 to infinity negative 1 raised to m over 2 raised to 2m plus v times m permutation times r open close m plus v plus 1 times x squared m. Ang susunod na gagawin natin, yung equation 1 natin, ipapasok natin sa equation, mali. Yung equation 2 natin papasok sa equation 1. Kaya naging yx equals to C1 x raised to 1 over 3 summation of m equals to 0 and infinity negative 1m raised to m over 2 raised to 2m plus 1 over 3 times m permutation r open m plus 1 over 3 plus 1 close parenthesis x squared m plus C2 x negative 1/3, naging negative 1/3 naman siya. Summation of m equals to 0 infinity times negative 1 raised to m over 2 raised to 2m minus 1 over 3 times m permutation r m minus 1 over 3 plus 1 x squared m. Ang susunod na gagawin naman, isi-simplify siya. Isi-simplify. Yung ang makikita natin dito, yung sinimplify, yung gawin ng dun sa r times m plus 4, ano nga yun? R times m minus 1 over 3 plus 1. Ginawa siyang m plus 4 over 3. Sinimplify, pinag-plus yung 1/3 saka yung 1. Ganun din yung ginawa sa baba. Yung negative 1 over 3, pinag-plus, plinasan ng 1, kaya naging 2 over 3. Next, gagawan naman natin siya nung m equals sa 0, 1, saka 2. And so on. Ipapalit natin doon sa m. Kaya ang lumabas, C1x raised to 1 over 3 times 1 over 2 raised to 1 over 3 r times 4 over 3 minus 1 over 2 7 over 3 r times 7 over 3 x squared plus 1 over 2 raised to 13 over 2 r 10 times 10 over 3 x to the 4th plus C2 x minus 1 over 3 times 1 over 2 negative 1 over 3 r times 2 over 3 minus 1 over 2 raised to 2 over 3 r times 7 over 3 x squared plus 1 over 2 raised to 11 over 3 2r 8 over times 8 over 3 x to the 4th. Pagkatapos naman nun, yung r niya, hahanapin natin sa table. Kagaya nitong r 2 over 3. Ito yung table niya, r 2 over 3. Makikita natin dito na yung r 2 over 3, ang value niya 1.35412. Kaya isinubstitute natin siya doon. Susunod, hanapin natin yung R 4 over 3 pala yung una. R 4 over 3. Ito R4 over 3, 0.89298. 0.8928. 0.8928. Susunod na hanapin natin yung R over 7 over 3. 7 over 3. by 7 over 3. Ayun, yung 0.90559. Ay, 5 over 3 pala yun, 5 over 3. Tapos, ang susunod na hanapin natin yung R8 over 3. 8 over 3. 8 over 3. Ayun, yung value niya 2.778. Ang susunod naman yung 1 over 3, yung R2 over 3, yun nga yung una kong sinabi na 1.35412. Ang next na hanapin yung R 5 over 3. 5 over 3. Saan may calculator? Ito yung value niya. Tapos yung value ng R8 over 3 naman, itong 1.50682. Tapos ang susunod na lang dyan, isi-simplify siya. Tapos ang makukuha natin sa isi-simplify na to, yung final answer na. At ito yun, yung yx equal to c1 x1 over 3 open 0.88850 minus 0.16666 x squared plus 0.008928 x raised to 4 plus c2x negative 1 over 3 open 0.9305 minus 0.6979 x squared plus 0.62617 x raised to 4. Yun yung final answer na nakuha natin. Ito yung gamma function table. Next, ito ipoprove natin yung derivative ng x nj x. Isa to sa properties ng Bessel function ng first kind. Pinakita dito na kung paano na-solve yung x n j n minus 1. Kapag nakita natin yung ganito, ang gagawin lang sa kanya, yung n niya ma-minus na ng 1. Yun. Sabi naman, derivative d over dx ng x minus negative njn x. Ang ginawa naman dito, naging negative yung x tapos nag-plus 1.
This is the continuations of the Bessel functions, the generating functions, and miscellaneous results. The problem 10.11 proved that the quantity z over 2, quantity t minus 1 over t is equal to summations of n is equal to negative infinity to positive infinity. The Jn is quantity x t over n, and the first step is we have to expand the left sides of the problems. The e quantity z minus 2, quantity z minus 1 over t is equal din siya sa e zt over 2 and e negative z over 2t is equal to negative summations of r equals 0 to infinity, and xt quantity xt over 2 raised to r over r factorial. And next is the summations of summation k equal to 0, k equal 0 to infinity. Negative x, quantity negative x over 2t raised to k over k factorial is equal to, dito yung pagsasamahin yung mga naka-summations. Yung summations of r equal 0 to positive infinity. And summations of k equal to 0 to positive infinity. Or negative 1 ay quantity negative 1 over k and quantity x over 2 raised to r plus k and t r minus k over 2 r factorial and k factorial. And the next step is, and let r minus k is equal to n. So that n varies from negative infinity to positive infinity. Then the sums becomes is summation n equal negative infinity to positive infinity, and summations of k equals 0 to positive infinity. Negative 2 ay quantity negative 2 k equal ay negative 1 raised to k, and quantity x minus 2 n plus 2k ay quantity x over 2 raised to n plus 2k, and t n over n plus k factorial n times k factorial, and equal, and the next step is equal to summations n equal negative infinity to positive infinity, and quantity close parenthesis negative summations of close parenthesis summations of 8 ay summations of k equals 0 to positive infinity, and close parenthesis negative 1 raised to k, and another close parenthesis x over 2 over n plus 2k over k factorial n plus close parenthesis n plus k factorials, and t raised to n equal to n summations of n equal positive infinity to negative summations of n equal negative infinity to positive infinity, and jn equal to x quantity x t n close parenthesis x t n. This is the final answer of these problems. Then the next problem is prove part 1 is letter A is cos. Dapat nating ma-prove na yung cos equal close parenthesis x and theta is equal to j sub 0 equal ay close parenthesis x plus 2 j sub 2 close parenthesis x cos 2 theta plus 2 j sub 4 close parenthesis x cos 4 theta plus and so on. And the next is B. And dapat din nating ma-prove yung sin x is close parenthesis x sin theta is equal to 2j sub 2 close parenthesis x sin theta plus 2j sub 3 close parenthesis x sin 3 theta plus 2j sub 3 close parenthesis x sin 5 theta plus so on. In the first step, let t is equal to e over 10 in problem 10.11. Then e raised to 1 over yung ilet daw natin yung t equal e over 10 doon sa nakaraang problem sa 10.11 dito. Sa 10.11 yung e is equal to 10 over e over 10. Then the first step is e 1 raised to 1 half z close parenthesis e raised to 18 e raised to 80 e raised to 10 minus e raised to 10 is equal to e raised to z sin theta is equal to summations of negative infinity to positive infinity and j sub n x 1 close parenthesis x e and n theta is equal to summations of negative infinity to positive infinity j sub n close parenthesis x and multiply to cos n theta plus I sin n theta. Then equal to j sub 0 close parenthesis x plus j sub negative 1 x plus j sub 1 close parenthesis x and cos theta plus j minus 2 raised to x plus j sub 2 quantity x cos 2 theta plus and so on. And the next is plus I quantity j sub n close parenthesis x minus j sub negative 1 quantity close parenthesis x and sin theta plus j sub 2 x close parenthesis x negative j minus 2 x close parenthesis x and sin 2 theta plus so on. And is equal to j sub 0 close parenthesis x plus 2j sub 2 close parenthesis x cos 2 theta plus and so on plus I and close parenthesis 2j sub 1 and close parenthesis x sin theta plus 2j sub 3 close parenthesis x sin 3 theta. And Berhebius. And the next steps is we have used to problem 10.3, the equating real and imaginary parts gives the required results. Dapat yung equating reals tas imaginary lines is yung may bigay niya yung parts ng required and may bigay niya yung parts ng required results. And the next is the problem 10.14. Prove the results of problem 10.6 for the integers of n by using the generating functions. Differentiating both sides of the generating functions with respect to t, we have omitting the limits negative infinity to positive infinity for n. The first step is e close parenthesis x over 2 and close parenthesis t minus 1 over t. And x over 2. And close parenthesis 1 plus 1 minus t squares equal to summation of n j sub n and close parenthesis x t over n minus 1. Or pwede rin x minus x over 2 plus 1 plus t over square. Summation sum j sub n close parenthesis x t raised to n is equal to summations of n j sub n x close parenthesis x and t n minus 1. And the next is the summation of x minus 2 quantity close parenthesis plus 1 over t over 2 and j n x close parenthesis t over n and summations of n's j sub n and negative pas ay close parenthesis x t n minus 1. This can be written as summations of x over 2 and j sub n and close parenthesis x t over n plus summations of x over 2 and x over 2 j sub n close parenthesis x t raised to n minus 2 equal to summations of n j sub n x close parenthesis x t n minus 1 or pwede rin siyang summations of x minus 2 and j sub n close parenthesis x t over n plus summations of x over 2 j sub n plus 2 close parenthesis x t over n is equal to summations of close parenthesis n plus 1 and j sub n plus 1 close parenthesis x t raised to n. Either summations of close parenthesis x minus 2 j sub n close parenthesis x plus x minus 2 j sub n plus 2 and close parenthesis x and t over n equal to summations of close parenthesis n plus 1 j sub n plus n and close parenthesis x and 2 times n ay 2 raised to n. And the next problem and the continuations of this is the continuations of the problem 10.14. Since the coefficients of t over n must be equal, we have to x over n, x over 2 and sub n equal to a quantity x plus x over 2 j sub n plus 2 quantity x equal to n plus the quantity equal to quantity close parenthesis n plus 1 and j sub n quantity a close parenthesis x from which the required results obtained in replacing n by n minus 2. Nireplace daw yung n by the n minus 2. Teka lang. May nalagpasan po tayong problem. The 10.13. The puro jn close parenthesis x is equal to 1 over pi. An integral of pi 0. Integral of pi 0. The cos close parenthesis n theta equal to x sin theta and d theta. And yung n na is equal to 0, 2, 3, and so on. The first step, multiply the first and the second results from problem 12. Yung first and second result daw yung multiply sa problem 10.12. This is the problem 10.12. By cos n theta and sin n theta respectively, and integrate from 0 to pi using integral of pi over pi sa integral pi 0 cos m theta cos n theta derivatives theta is equal to 0 m not equal to n, and pi over 2 m is equal to n, and the integral of pi 0 sin m theta sin n theta derivative theta is equal to, yung 0 niya is yung m not equal to n. Yung pi over 2, yung m equal to n not equal to 0. Then if n is even or 0, we have j sub n, close parenthesis x is equal to 1 over theta, integral of x 0, cos close parenthesis x sin theta, and cos n theta, derivative theta. Yung 0 and 0 is equal to 1 over pi derivatives pi 0 sin close parenthesis x sin theta and sin n theta, derivative theta, or on adding o di kaya i-adding the j and quantity x equal to 1 over pi derivative integral x 0 close parenthesis x ay cos close parenthesis x sin theta cos n theta plus sin close parenthesis x sin theta and sin times sin theta and derivative theta equal to 1 over pi. This is the result of these equations. The 1 over pi integral yung pi 0 cos n theta minus x sin theta. Close parenthesis siya. Naka-close yung cos, close parenthesis n theta minus x sin theta. Yung d theta. Similarly, if n is odd. Yung similarly daw, yung n daw is odd number. J sub n, close parenthesis x minus 1 over pi, integral pi over 0, sin, close parenthesis x sin theta, sin n theta d theta. And 0 is equal to 1 over pi, integral of pi over 0 cos x sin theta and cos n theta d theta. By adding naman daw yung gen x equal 1, j sub n close parenthesis x is equal to 1 over pi integral of pi 0 cos close parenthesis n theta minus x sin theta and derivative theta. And thus we have the required results whether in n is even or odd. The n is equal to 0, negative 1, negative 2, and so on.
Dito pag-aaralan naman natin yung function related to Bessel function. Meron tayo dito, prove that the recurrence formula for the modified Bessel function of the first kind, I sub n parenthesis x parenthesis given by I sub n plus 1 parenthesis x parenthesis equals I sub n minus 1 parenthesis x parenthesis minus 2n over x I sub n parenthesis x. Meron tayong sa problem 10.6, meron tayong j sub n plus x parenthesis x equals 2n over x j sub n parenthesis x equal j sub n minus x minus 1 parenthesis x. Yun yung equation number 1 natin. Meron naman dito yung x, ay papalitan natin siya ng ix. Magkakaroon tayo ng, na-obtain natin ay j sub n plus 1 parenthesis ix. Nalagyan natin ng ix yung x. And equals negative 2in over x j sub n parenthesis ix minus j sub n minus 1 parenthesis ix. Ayan yung equation 2. Meron naman ito. Now, by the definition, I sub n parenthesis x equals I n j sub n parenthesis ix or j sub n parenthesis ix equals I raised to n I sub n parenthesis x. So that's 2 becomes. Ito naman yung mangyayari dyan. Magiging ano siya. I raised to n plus 1 tapos I sub n plus 1 parenthesis x equals negative 2in over x and in I sub n parenthesis x negative I raised to n negative 1 I sub n parenthesis x dividing by I raised to n plus 1 then giving the required result. Ito na yung sagot niyan. If n is not integers, show that kapag daw yung n is not integers, mangyayari ay h raised to positive 1 and sub n parenthesis x equals j sub negative n parenthesis x minus e raised to negative in pi and j sub n parenthesis x over I sin n pi. Yung sabi naman, meron tayong yung b naman natin yung h sub n raised to 2 parenthesis x equals e raised to in pi j sub n parenthesis x minus j sub negative n parenthesis x over I sin n pi. By the definition of h sub n raised to 1 parenthesis x and y sub n parenthesis x. The C page 226 and 225 respectively, we have meron tayong h sub n raised to 1 parenthesis x equals j sub n parenthesis x plus iy sub n parenthesis x equals j sub n parenthesis x plus I column j sub n parenthesis x cos n pi minus j sub negative n parenthesis x over sin n pi kolo. Ang makukuha naman natin dyan ay j sub n parenthesis x sin n pi plus ij sub n parenthesis x cos n pi minus ij sub negative n parenthesis x over sin n pi. I-divide natin naman siya sa i. Ihiwalay natin yung i, ilalabas natin. Kaya ang mangyayari, kasi common sa kanila yung i. Pag nilabas natin, ito mangyayari. I column j sub n parenthesis x parenthesis cosine n pi minus I sin n pi parenthesis negative j sub negative n parenthesis x over sin n pi column. Equals naman siya sa I column j sub n parenthesis x e raised to negative I n pi minus j sub negative n parenthesis x over sin n pi column equal siya sa j sub negative n parenthesis x minus e raised to negative I n pi and j sub n parenthesis x over I sin n pi. Sabihin naman natin yung since h sub n raised to 2 parenthesis x equals j sub n parenthesis x minus iy sub n parenthesis x, we find on replacing I by negative I in the result of the part A. Ibig sabihin, yung I, papalitan natin siya ng negative I. Kaya meron tayong h sub n raised to 2 parenthesis x equals j sub negative n parenthesis x negative e raised to I n pi j sub n parenthesis x over negative I sin n pi. Equal siya naman siya sa e raised to I n pi j sub n parenthesis x minus j sub negative n parenthesis x over I sin n pi. Ito naman yung equation transform into Bessel equation. Find the general solution of the equation x, y, double prime plus y prime plus ay equals 0. Sabi rito, the equation can be written as x squared y double prime plus x y prime plus axy equals 0 and is a special case of equation 24, page 226, where case equals 0, yung alpha naman natin ay equal siya square root of a, as yung r ay equals 1/2, yung beta naman equal siya naman siya sa 0. Then the solution is given by 25, page 226 in is y equals first kind solution j sub 0 quantity 2 square root of ax plus yung second kind solution naman natin yung y sub 0 quantity 2 square root of ax. Meron naman tayo dito yung orthogonality of Bessel function. Sabi rito, prove that meron tayong integral ng 1 and 0 xjn sub n quantity ng lambda x j sub n quantity ng mu x dx equals naman siya sa mu j sub n quantity ng lambda j prime sub n quantity ng mu minus lambda j sub n quantity ng mu tapos j sub n prime quantity ng lambda over lambda squared minus mu squared if quanta is not equals to mu. Sa page na 5 and 4, sa page 224, makikita natin yung y1, y sub 1 equals j sub 1 quantity ng lambda and x and y sub 2 equals j sub n quantity ng mu x are the solution of the equation. Ito yung solution niya. Yung x squared y double prime sub 1 plus x y sub 1 prime plus quantity ng lambda squared x squared minus n squared y sub 1 equals 0. Sunod naman dito yung x squared y sub 2 raised to double prime plus x y sub 2 raised to prime plus quantity ng mu squared x squared minus n squared quantity and y sub 2 equals 0. Sabi rito, by multiplying the first equation by y sub 2, the second by y sub 1 and subtracting, we find meron tayong x squared colo y sub 2 y sub 1 raised to double prime minus y sub 1 y sub 2 raised to double prime colo plus x colo y sub 2 y sub 1 raised to prime minus y sub 1 y sub 2 raised to prime colo. Equals naman siya sa quantity ng mu squared minus lambda squared quantity x squared y sub 1 y sub 2, in which on division can be written as, i-divide natin naman siya sa x d over dx derivative colo y sub 2 y sub 1 raised to prime minus y sub 1 y sub 2 raised to prime colo plus colo y sub 2 y sub 1 raised to prime minus y sub 1 y sub 2 raised to prime colo equals naman siya sa quantity ng mu squared minus lambda squared quantity x sub 1 x y sub 1 y sub 2, or pwede siya maging ganito, d over dx colo x colo y sub 2 y sub 1 raised to prime minus y sub 1 y sub 2 raised to prime colo equals naman siya sa quantity ng mu squared minus lambda squared quantity x y sub 1 y sub 2. Then by integrating and omitting the constant of integration, magiging ganito siya. Quantity ng mu squared minus lambda squared integral x y sub 1 y sub 2 dx equal siya sa x colo y sub 2 y sub 1 raised to prime minus y sub 1 y sub 2 raised to prime colo. Sa continuation naman, yung using naman ng y sub 1 equals naman siya sa j sub n quantity ng lambda x sa ano naman sa y sub 2 equals j sub n quantity ng mu x and dividing by mu squared minus lambda squared is not equal to 0. Kaya meron tayong makukuhang integral ng x sub n x j sub n quantity ng lambda x quantity j sub n quantity ng mu x quantity dx equals naman siya sa x colo lambda j sub n quantity ng mu x quantity ng j sub n raised to prime quantity ng lambda x quantity minus mu j sub n quantity ng lambda x quantity j sub n raised to prime. Meron pa tayo nitong quantity ng fume x kolo. Over naman siya sa, kasi i-divide natin, kaya magiging over siya sa mu squared minus lambda squared. Tapos, yung integral natin ay 1 ay 0. Ito na mangyari, lalagay natin yun. X, J, N, J sub N, quantity ng lambda X, J sub N, quantity ng mu X dx equals lambda, J sub N, quantity ng mu, J sub N raised to N, quantity ng lambda, minus naman siya sa mu J sub N, quantity ng lambda. And J sub N raised to prime, quantity ng mu, over, so i-divide natin siya dito, over mu squared minus lambda squared. Ito kailangan naman natin i-prove that integral ng 1 and 0 x j sub n raised to 2 quantity ng lambda x dx equals manap kolo j sub n prime to quantity lambda plus quantity ng 1 minus n squared over lambda squared quantity j sub n raised to 2 quantity ng lambda kolo. Yung mu ay gagawing lambda in the result of the problem 10.21. Then using the L'Hospital rules, we find integral ng 1 and 0 x j sub n raised to 2 quantity ng lambda x dx equals yung limits, yung mu limits papuntang lambda, lambda j sub n raised to prime quantity mu j sub n raised to prime quantity ng lambda minus j sub n quantity lambda j sub n raised to prime quantity mu minus mu j sub n quantity lambda and j sub n raised to double prime quantity mu over 2u. Kaya makukuha nating sagot ay lambda j sub n raised to prime 2 quantity lambda minus j sub n quantity lambda j sub n raised to prime quantity lambda minus lambda j sub n quantity lambda j sub n raised to double prime quantity lambda over 2 lambda. But sin lambda squared j sub n raised to double prime quantity lambda plus lambda j sub n raised to prime quantity lambda plus quantity lambda squared n squared quantity j sub n quantity lambda equals 0. We find solving for j sub n raised to double prime quantity lambda, yung substitute natin siya sa integral ng 1 and 0 x j sub n raised to 2 quantity ng lambda x dx equals 1 half kolo j sub n raised to prime 2 quantity lambda plus quantity 1 minus n2 over lambda squared j sub n raised to 2 quantity x kolo. Prove that if lambda and mu are two different roots of the equation, rj sub n quantity x plus s xj sub n raised to prime quantity x equals 0, where r and s are constant, ibig sabihin yung r tsaka s ay constant. Then, integral 1 and 0 xj sub n quantity lambda x, j sub n quantity mu x dx ay equal sa 0. I-equal sila sa 0. Etc. Square root of xj sub n quantity lambda x and square root of xj sub n quantity mu x are orthogonal in 0, and 1. Since lambda and mu are root of rj sub n quantity x plus sx j sub n raised to prime quantity x equals 0, meron tayong rj sub m quantity lambda plus s lambda j sub n raised to prime quantity lambda equals 0. So naman dito, meron tayong rj sub n quantity mu plus s mu j sub n raised to prime quantity ui equals 0. Then, sabi rito, yung r ay not equal sa 0 and x is not equal to 0, we find from equation number 1 yung mu j sub n quantity lambda j sub n raised to prime quantity mu minus lambda j sub n quantity mu j sub n raised to prime quantity lambda equals to 0. And so the problem 10.21, we have the required result. Makuha naman natin dito yung integral ng 1 and 0 x j sub n quantity lambda x j sub n quantity lambda x dx ay equals to 0. In case naman dito yung r equals to 0, yung s is not equal to 0, or yung r is not equal to 0, yung s ay equal to 0. And the result are easily provided yung kasunod niyan. Observation, naman tayo dito ay series of Bessel function. If quantity f quantity x equals summation of p equals 1 and infinity a sub p j sub n quantity lambda sub p x and 0 greater than x and x greater than 1, where lambda sub p and p equals 1, 2, 3, etc. are the positive root of j sub n quantity x equals 0, show that a sub p equals 2 over j sub n plus 1 raised to 2 quantity lambda sub p integral ng 1, 0 xj sub n quantity lambda sub p x f quantity x dx. Meron tayong multiplying the series for f quantity x by x j sub m and quantity lambda px and integrate term by term from 0 to 1. Kaya ang mangyayari ay integral ng 1 and 0 x j sub n quantity lambda px f quantity x dx equal naman siya sa summation ng p equals 1 infinity a sub p integral ng 1 and 0 x j sub n quantity lambda px j sub n quantity x sub p x dx equals naman siya sa a sub k integral 1 and 0 x j sub n raised to 2 quantity lambda sub kx dx. And equals naman siya sa 1 half k sub k j sub n raised to prime 2 quantity lambda sub k. Sabi naman dito, where we have used the problem 10.22 and 10.23 together with the facts that j sub n quantity lambda sub k equals to 0. It's followed that a sub k equals 2 sub over j sub n prime to quantity lambda sub k, integral siya ng 1 and 0 x j sub n quantity lambda sub kx and f quantity x dx. To obtain the required result from this, we note that from the recurrence formula 3, page 225, which is equivalent to the formula 6 on the page web. Kaya mangyayari yung lambda sub k j sub n prime raised to prime quantity lambda sub k equals naman siya sa n j sub n quantity ng lambda sub k minus lambda sub k j sub n plus 1 quantity ng lambda sub k. Kaya ang mangyayari doon, or since the j sub n quantity lambda sub k ay equal sa 0. Kaya ang mangyayari, magiging 0 to. Kasi siya ay equal sa 0. Kaya ang matitira na lang sa equation natin ay yung j sub n raised to prime quantity lambda sub k equals negative j sub n plus 1 quantity lambda sub k. Kaya ito na natira kasi yung j sub n quantity lambda sub k ay equal sa 0 kaya magiging 0 ay mawawala. Yung i-expand naman natin yung f quantity x equals naman siya sa 1 in the series of the form for 0 greater than x and x greater than 1 if 1 the sub p, yung p ay equals naman sa 1, 2, 3 and so more sa positive roots of j sub 0 quantity x equals to 0. Sa problem na meron tayo, yung mangyayari naman dito yung a sub p ay equals naman siya sa 2 over j sub 1 raised to 2 quantity lambda sub p. Integral naman siya ng 1 and 0 xj sub 0 quantity lambda sub p x dx ay equals naman siya sa 2 over lambda sub p raised to 2 j sub 1 raised to 2 quantity lambda sub p. Integral naman siya ng lambda sub p 0 and b j sub 0 quantity b db equals siya sa 2 over lambda sub p raised to 2 j sub 1 raised to 2 quantity ng lambda sub p and b j sub 1 quantity b integral ng lambda p 0 equals 2 over lambda sub p j sub p quantity lambda sub p. And magkaroon tayo ng substitution, yung b ay equal sa lambda sub p x in the integral and use the result of the problem. Sa 10.8 yung which yung n natin ay equal sa 1. As we have the required series na f quantity x equals 1 equals summation of p equals 1 infinity and 2 over lambda sub k j sub 1 quantity lambda sub p j sub 0 quantity lambda p x. Pwede siyang written na j sub 0 quantity lambda 1 quantity lambda sub 1 x over lambda sub 1 j sub 1 quantity lambda 1 plus j sub 0 quantity naman siya ng lambda sub 2 x over lambda sub 2 j sub 2 and quantity ng lambda sub 2 plus or equal siya sa 1/2. So, thank you for listening. Ipapakilala ko lang po yung group namin. Ito po siya i-submitan ng group number 2. Ang membro ko po ay si Centro Patrick B. Dito ako si Jervin B. Fuentes Rocky C. Ocampo Michael Angelo B. Tarucan RGR. Pinasa po siya ng BSCE 2D. Salamat po. Submitted to Engineer John Raymond Toledo, RE Professor.